today I want to spend a bit of time talking to you about how ARM, together with our ecosystem, is enabling what we've called here the endpoint ML revolution. And I've seen from the poll there's some degree of familiarity with this, but there's also some of you who haven't heard about this. So it's a great opportunity to kind of level set, and we'll go from there. So I want to talk a bit more about ARM first. ARM is the world's leading semiconductor intellectual property, or IP, supplier. And we are all about sparking the world's potential, from the tiniest of sensors to more than 99% of all smartphones, to the cutting edge of automotive design, to the largest cloud data centers, to the most powerful supercomputers. Our energy efficient processor designs and the software platforms have enabled advanced computing in more than 190 billion chips. I'll say that again, 190 billion chips. And our technologies securely power products right from the sensor through to the smartphone, through to the supercomputer. And together with over 1,000 technology partners, we're right at the forefront of designing, securing, and managing all areas of AI-enhanced connected compute, right down from the chip to the cloud. Now, I'd like to take a moment and step back, and I want to look at machine learning and how we got here. It really kicked off in hyperscale data centers. Why is that, you ask? Well, that's where the big example data sets were. Now, as we all know, the most important computational problem facing the world is naturally identifying pictures of cats. Shown some examples here. And if you want to identify pictures containing cats, well, you need billions of annotated pictures of cats to train your ML models with. And I've mentioned here training specifically and deliberately because it's really important, as you probably know, to distinguish this training from inference, because they're separate compute problems. They have very separate deployment requirements. Because training your model requires huge storage, massive compute, and vast runtimes. Historically, the cloud and the hyperscale data centers is where most people experiment to design, discover new neural networks. And it's been there today and potentially going to be there for the foreseeable future. So if you want to train your models, then doing it near those example data sets does make a world of sense. But the center of gravity is rapidly expanding to endpoint devices. Why? Well, that's where the input data is. That's the data that you want to process and test when you use those models for inference. And that means developing ML models that work well on the tiniest devices and small, low power processors optimized to run those models. You've got to develop them. And so training occurs in the cloud, yes. And there are steps to do more training on device, granted. But today, the bulk of the inference is happening on the endpoint devices, on these tiny microcontrollers. And this inference occurs across a wide variety of use cases. And we generally break them down into what we call the 3 V's: voice, vision, and vibration. Now, aside from being where the data is, why else is AI and ML moving to the edge? Why have we seen this growth in this industry? I want to expand a bit more here, starting off with bandwidth. If you want to shift massive amounts of data back and forth to the cloud to process, then back to the application, well, you're going to see a noticeable lag. You're going to see a noticeable delay. Now, as a user, that's going to be annoying. But it's not just about a better user experience. It's a cost factor as well, because shifting and storing data is huge in terms of cost. As an example, think about the number of installed connected HD cameras. The cloud can't take all of that HD video that users are taking, send it over the network. And particularly if you think about the increases in the number of cameras, the problem's only going to get worse. The internet would just simply break. When we look at power next, it takes a significant amount of power to transmit all of that data. And building more and more data centers, more and more server farms just is not the answer here to that ever-increasing data handling. Because enormous power consumption is needed to enable that to work. And that power costs money, yes, but it's also critically detrimental to our carbon footprint, to that carbon emissions. And that's really an increasing area of focus for many in the industry, particularly cloud service providers as well as consumers. Because in simple terms, a given amount of compute takes less power on an edge device than in a data center. Now, laws of economics come in here as well when you look at cost. The cost of transmitting that data, as I've already hinted at, is significant. And it's cheaper to do that computation on edge devices rather than in the cloud on servers, when someone else is paying for the cost of the computation. And it's not just us who are noticing these challenges and the data usage. Take Google. Google realized that if every Android user in the world used about 3 minutes of voice recognition time a day, they would need twice as much computing power to handle it all. Step back and think about it. The world's largest computing infrastructure, in other words, is going to have to double in size. That's just simply not economic. Look at latency. Time-critical applications like automotive applications, well, they can't rely on connectivity and the cloud. You've got to run some activity locally on device. In the example I've just given, the device is a vehicle, but the principle still stands. You need that capability at the edge. And that extends to reliability too. I'm sure we've already experienced times when our mobile phone has lost signal, or when the internet just seems to not respond as fast as we'd like or at all. Local on-device processing is needed to keep ML applications processing at their fastest speeds, and their fastest speeds in a reliable way. And then finally, security. And also adding on to this, I'd like to add on privacy too. Recent events are bringing security right to the forefront of users' minds. We're demanding it by right. And whilst ML is also enabling additional security measures on your device, some Android phones can now tell the user by their gait, their walk, and they can lock that phone if the walk is determined not to be the owner's. But tied closely to that is privacy. No one wants their data breached. The risk of that increases when it's constantly shifting between the cloud and the edge device. And users are actually increasingly demanding that privacy and that control of their data, particularly when that data is very personal and it's very sensitive. And that is often the case when you look at an ML model. Moreover, the protection of that data is actually being mandated by law. And so AI on the edge, why are we seeing this growth? Well, it's more responsive, it's more reliable, it's more secure, and your data is better protected because it doesn't leave the device. It's under your control. That's all behind endpoint ML and tinyML. What about ARM? Let's bring the focus back to ARM here. ARM is a world leader when it comes to AI. We combine powerful, scalable processors across CPUs, GPUs, and dedicated neural processing units, or NPUs, which are specifically designed for ML acceleration. We combine those processors together with software, tools, standards, and support needed to make AI sing. And combined with the diverse ecosystem, ARM and our partners are really sparking the world's AI potential. ARM AI truly is everywhere you look. I want to focus actually a bit more here on the software and the tool side of things, because the challenge for an AI developer who wants to use ML, vision, or other compute features is how to best target such a wide variety of processor types, because there's such a wide variety of combinations across the ARM ecosystem. And so the challenge of writing these applications that target these multiple platforms could be significant. When you look at ARM has we believe, the only complete heterogeneous compute platform for ML at the endpoint. We are the software framework of choice for edge devices, and not just mobile. We have flexible software frameworks which support these workloads across all of our programmable IP, and extend these to cover new features in existing IP as well as new core types too. when you look at targeting future platforms, it will simply be a matter of rebuilding the application and the potential in the longer term for even moving the stage as techniques for automatically scheduling workloads across all available cores and core types develop. So at Arm, we are focused on making the best machine learning user experience possible. That is our focus. For Arm and for this ML innovation, in each of the segments we target, we serve and that we service, it's not a one-size-fits-all approach. General purpose processors used to suit most needs for desktop computers, car electronics, but today, Arm and our partners, their needs for efficient processing have changed dramatically. They've doubled every couple of years, and they're accelerating faster. Now AI is driving an insatiable demand for compute. They're demanding specialist processing. Partners who are building these modern system-on-chips, SoCs, well, they need to configure different specialized processing elements to match those needs. And only Arm is investing to meet these needs for a range of IP, from the lowest cost devices in IoT right up to supercomputers. So with AI moving to the edge, as I've already discussed, the need for specialized processing cannot be overstated. And that is why when you combine Arm's CPUs, and NPUs in particular in this space, together with being the software framework of choice for edge devices, well, that's helping drive inference onto the edge. It's helping accelerate AI compute, and it's helping our ecosystem and developers harness the endpoint ML revolution. So Arm and AI, they're synonymous with one another, and we've got dedicated, purpose-built, specialized processing across the use cases. So let's take a look at the world of endpoint AI. As we've said, different computing problems need different mixes of computing components. And many of these edge and IoT devices that I showed in the previous slide, well, they need to interpret their results. They need to interpret their worlds. And a combination of the Cortex-M cores and something like the Ethos U55, well, that's perfect there for the world of endpoint ML and tinyML. The Cortex-M's flexibility, ubiquitous presence, and features such as the Helium extensions in the architecture, well, they provide the foundation for these embedded systems. But as we look ahead, dedicated ML accelerators like the Ethos U55 and the Ethos U65 take the possibilities to the next level. These products are a new class of machine learning processor, and they're called a micro NPU, because they're specifically designed to accelerate ML inference in tiny area-constrained embedded and IoT devices. They're designed to work in tandem with a Cortex-M, and in the case of a U65, a Cortex-A as well. And they easily integrate into existing designs. But they provide an order of magnitude increase in neural network performance, because they're designed specifically for this task, to accelerate neural networks. And when you combine that with that common software development environment, well, that's designed to make your development, your deployment easy, and takes maximum advantage of the system's power and its flexibility. Let's look at an example here, because again, this specialized processing approach I've spoken about that Arm has is designed to enable the next generation of on-device endpoint machine learning. So let's take a look at a typical machine learning workload for something like a voice assistant. When you look at this, our latest Cortex-M55 alone already provides a 6x speed up in inference times and a 7-fold increase in improvement in energy efficiency over Cortex-M7. But then you combine that CPU with that dedicated Ethos micro NPU. Here I've chosen the U55. The results are simply astonishing. You see a typical 50x inference speed up and a 25 to 75 times improvement in energy efficiency. Again, a 50 times inference speed up. That's incredible. Combined with that huge energy efficiency gain. Now, these numbers are truly astounding, and they give you a glimpse as to where the future of endpoint ML is going. It's really, really exciting how we're enabling this together with our ecosystem.